Hello C programmers, my name is Reza. Welcome to today's video. In today's video, I'm going to talk about passing the address of a variable to a function rather than passing a variable by value. To watch this video, you need to know pointers and functions. If you haven't watched those videos, link in the description. In future videos in this series, we're going to use functions and pointers a lot, and there will be tons of examples regarding functions and pointers, so pay attention. Let me write a function that increments an integer. So int, let's name it increment, and the function takes an integer var. You see that I put a semicolon here? It means that this line is just the definition of the function. It's like when we declare a variable, this is how we declare a function. To make my code cleaner, I can go ahead down here and add the description of the function. So I'll implement the function here. I'll repeat the first line. Int var. And now I can put the body of the function here. This way, when the compiler starts reading the code, it will see all my functions here before the main function and know how many functions I have in this code, get a sense of what are my functions in this code, and then the declaration will be after the main function, so the code wouldn't be messy. It would be much easier to read. You would see the main function first, and when you reach a function and you wanted to know what is the process that's being taken in that function, you'll be going to that function, see the operations in that function, and if you want to make a modify or change something, you will change it. It will make it much easier to read. So this, from now on in the course, we will declare the functions before the main function and then implement them after the main function. So be careful, if we don't have this here and use increment function in the main function, it would say that I don't know what is increment because you haven't defined it, you haven't declared it yet. If you want to use it later, you have to declare it first. Okay, so this function is just easy. It will return var plus 1. So it's an integer function. It will increment var and it will return it. If I create an integer here as result and probably another integer as var1, let's say var1 is 10 and result is equal to increment var1. And if I put a breaking point here at the beginning and start debugging my code. Okay, I forgot a semicolon here. F5. Okay, we are in debug mode. So you see that in this scope, in the scope of main function, I have two variables, result and var1. var1 hasn't been initialized yet because line 7 hasn't been executed yet. If I step over, var1 will change to 10. If we step into the function by pressing F11 or this button in Visual Studio, we will be into the function. In this function, we have an integer. So as soon as I got to line 13, this var will be created, but it hasn't been initialized yet because this line, the first line of the function, hasn't been executed. If that being executed, it means that this number 10 that we put it here, now it will be into the function. But you need to know, as I said in the function video, this var is different than this var1. It's a copy of this. So now this var1 hasn't been sent to the increment, a copy of this. This 10 is somewhere in the memory, and this 10 is somewhere else in the memory. I have two integers with a value of 10 in different parts of my memory. It is a copy of var1. Okay, so the copy of var1 will be incremented. and will be returned to the main value. If I step over, so we go back to the function, you see that the increment function returns 11. It's now not 10 anymore, and the result is 11. And go on. So that's what's happening here. Result is 11. Sometimes I want to put it back into var1. Okay, if I change the result to var1, you see that var1 didn't change because it was a copy of var1 that we used in the function. Now if I change it to var1, change the result to var1, and restart debugging this code. Because I declared it, I don't need to declare it. I just need to say var1 is equal to increment. Restart debugging. Okay, cool. So you see var1 hasn't been initialized yet. If I step over, var1 is 10. Step over again, you would see that the return of the function is 11. Now var1 is 11 too. So this is one way to do it, using a return function. One other thing that you need to be careful here, we can do that by manipulating the memory address of var1 here. We don't need to have a function that has an integer return value. Let's do that. The problem with this code is if I don't have this var1 here, and if I restart debugging, the value of var1 will be 10, and then the increment function, and the value of var1 will stay 10 because we didn't change it. We only changed a copy of var1. We didn't change var1. So one solution is to change this function to void. Now this function doesn't return anything. I have to change this declaration as well. So now these two declarations match each other. Instead of returning var, I would say var plus plus. So if I restart debugging, what will happen? This way, this var plus plus is identical to var equal to var plus 1. So now I'm updating var variable inside the function. Let me step over and then jump into the function. And as you can see, let me go to locals here. Local variable var is being created here. It's now 10 because it's initialized. And after this line, var is 11. And if I go back, I see still var1 is 10 because variable var is now deleted after line 15. It does not exist in this program after line 15. Okay, so this function is basically doing nothing. If I remove it from my code, nothing will happen. As a matter of fact, when you wanted to release your software, instead of debugging and you compile your code for release, C would ignore this function for you because this does not do anything in your code. This doesn't change anything in your code. But here, there could be a solution. So I can increment var1 using this function instead of just incrementing a copy of var1. So here, instead of sending a copy of var1, I'm putting int star var. It means what? It means I'm sending a pointer to var1 here, an address to this function. This function takes an address. Let's actually change the name to ptr. So that makes, of course you can leave it var, but I want to change the name to ptr so it makes sense that this function takes a pointer, takes an address. I have to modify this here as well. ptr. Oh, sorry. And then here, ptr plus plus. Okay, now here, the function takes an integer, but takes an address, but I'm sending a value to it, a value of a variable to it. I have to send the address. You remember in a scanf function or in pointer video that we put ampersand to send the address of a variable. Now in this function increment, I'm sending the address of var1 instead of a copy of the value of var1. A copy of the value, when you get a copy of a paper, whatever you modify on that paper, it wouldn't change the same. It wouldn't change the paper. But if you get the same paper and modify it, you're changing the content of that paper. Okay. So let's go back to our example here. But this is still not working. There's a problem here. I'm taking an address and then say address plus. Let me get rid of this comment here. What I'm doing here, I'm incrementing the address. So if I'm pointing to this position in my memory, now I'm pointing to the next position because I'm incrementing the address. For example, if you're looking at unit 13 in one street and a home in one street, unit 13, for example, if you increment it, you're going to look at unit 14. Now, what the problem is, you don't want to do that. We want to increment the value attached to this address. That's where dereferencing come in. If I put an asterisk before PTR, it means I'm dereferencing it. I'm accessing the value that pointer is pointing to. So there is an address, but there is a value in that address. In our home example, there are different homes, but there are people living in that home. There are things that are happening in those homes. Those are the value of those addresses. So if I wanted to access that address, I have to enter that home. I have to put my pizza box on the counter. So I wanted to access that home. To access whatever is in an address, you have to dereference it using an asterisk. But still, this code, there's something wrong with this code. The problem is, with C programming, there are priorities in doing operations. C++'s priority here is to do this part first and then dereferencing it. Okay, so what will happen here, we'll go from unit 13 to unit 14 and read the value of unit 14. We don't want that. We want to dereference the pointer first. We are at the location that this number 10 has been stored. We want it to get to the value, which is 10, and increment 10. We don't want it to go to the next memory position and increment that, whatever is that there. We won't increment it. We will access it because we already increment the address. So what will happen here, to make sure that this will happen first, I'll put it inside parentheses. So now this code, I will dereference PTR, then increment it. Let's see if it's working or not. I'll put a break. Yeah, we do have the breaking point. Let's restart debugging. Okay, so var1 not initialized. Step over var1 is 10. If I step over, var1 will be 11. But let's just start debugging and jump into the function to see what is happening in the function. If I step over, now we're at the function, var1 is 10. Now here, the address of var1 is sent to the function. The function's input argument is a pointer, is int star. It's not int anymore. Step to the function, and now we're at line 13. You see that a pointer created and the value of the pointer is null. If I step over, the value of this address is identical to the address of var1. Let me actually do something here. So if I create, if I put a int star temp and it equal to the address of var1, I just wanted to show you that this is exactly the same address. This is identical to the address of var1. So if I restart debugging, okay, so temp will be null after this line, temp will be, let me actually copy this, go to the debug, Windows, memory and memory 1, and search for this memory address. Let's get rid of these extra parts that we don't need. This is the variable temp. Okay, if I hit enter, we will set here 0A is just the way that compiler used to store 10. Now keep that address in mind. If I step over that line, which is, we are at the function line. If I step into the function, now the pointer in the function is null. And now you see that the address is exactly the same address that I put here. So temp and ptr is identical. It means that in this function, I'm working with the same memory address that I used to save var1. Okay, so what happened if I step over this line? Okay, you see that the value that this address is pointing to changed to 11. Now, if I go back to the step out of this function, go back to the main function, you see the value of var1 is also changed. So this way, I can modify the variables I have in the main function in my other function. Basically, you can modify all the variables that you have in one scope using your function, because we know that this variable exists in this scope. But I want to have access to this variable in other scope, in this case, in this function's scope. So I just send the address of it. And this way I can work with it because it's still alive. When we reach this line, we haven't get to the closing bracket for closing curly bracket. It means that this integer variable is still alive. I send the address of it to the function. Now I can access that address, modify it, do whatever I want. And that's the novelty of C and C++ program. Okay, in this video, we were successful to pass a variable by its address to a function and manipulate the value that this address is pointing to using dereferencing and pointers inside the function. This way, we can declare our variables in one scope and modify the variables we declared in that scope using function, which is another scope. That's amazing that we can do a lot with it. Now functions are not just limited to the return statement, so you can only return one value. You can return a lot value. You can send the pointer of uninitialized variables and then put whatever you want in them. So basically, as I told you, using pointers, sky's the limit. This concludes our video for passing address to a function. We will going to use this a lot. I would say literally in every episode from now on. Thank you for watching this episode. Have a great day. And as always, see you in the next video.